So hello, thank you so much for inviting me for the interview. My name is Siavash Ahrar. I'm an assistant professor, which means a new professor in CSU Long Beach. And I work in biomedical engineering, but I really think of myself as a bioengineer. So my lab is made out of entirely undergrad students, and we work on a couple of cool projects. I'm going to pick one that I'm really excited about. Not that the others are not good, but we are building tools to study aquatic organisms. So we build very cheap microscopes and these fluidic homes, essentially, if you will, these fluidic chips to study sand dollar larvae. These are like, when they grow up, they look like a giant circle, but when they're young, they look like the stealth bomber, essentially. And we were trying to, and also Hydra, which is like this crazy organism that if you cut it, you end up with two. And I can tell you all about that. But why we're working on these is because we want to use their hydrodynamics, like how they move inside the liquid environment and how they respond to various, environmental factors as a model to understand the impact of climate change on various organisms. And we're not biologists, and we love biology. We work with amazing biologists, but we're engineers. So our approach is like we're smart enough to know that we know very little biology given our background. So we partner up with awesome biologists. So our approach is broadly to build tools that help biologists do their research and slowly begin to ask our own questions from an engineering perspective. So, that's a great question. And I think folks can contribute based on what they know. And as long as they're happy to learn, like as long as you're willing to engage with the problem, think about it deeply. And if you have gaps in your knowledge, willing to fill it, I think you can begin to learn and contribute. Like I don't, when I started my undergrad studies, I was not a bioengineer. And I went to a high school outside of the US where we had to pick a major. So I was a kind of like a physics and math track student. So the first biology course that I took was in college. And that was, like, in all honesty, the first ever biology course I had ever taken. It's like probably my lowest grade ever. But I really liked it. Because it was really new. I had no idea what was happening. Like genuinely, like I think I barely passed the course, and it ruined my GPA. But it kind of didn't matter because I was just like, this is really cool. So I started my research as a biomedical engineer, working on similar types of stuff while I did not know any biology. But I actually grew to like it. At the beginning, I was not at all excited about learning biology. It seemed like a chore, but it kind of changed over time. To go back to one point that I guess maybe I didn't do a good job of emphasizing is that, like, we love to learn biology, but when I say we bring an engineering perspective to it, I really like building stuff. Essentially, like I've always been into kind of like making new types of tools, making devices, working on projects. So when I was in high school, I was part of a theater group that we worked on putting on the, I guess the light pieces for the production. So that was the thing that excited me, like building stuff. So we are at a place in bioengineering that we can build stuff for, studying biology or build with biology itself. And as long as that's a perspective that you bring in, I think you can contribute to the field and you can grow and learn. So, I thought about this question, and I wish I had like a very like a neat or like profound answer. I think that, like throughout, so I've always been a little nerdy and academic. So there were a lot of, and I read a lot. I read very broadly. And there were a lot of research papers that really genuinely captivated my imagination. I had no idea when I first read some of those papers what they were really talking about. Like I did not at all understand the biology, but I just really liked the idea, right? I was like a second year undergrad in electrical engineering, reading a paper about kind of building, I guess, clock-like circuits inside bacteria. I did not really know what was a genome, like how bacteria like worked, but I just really, liked the idea. There's like, oh, this sounds genuinely, it just sounds cool. And there were a couple of other papers similar. So that's how, like, I think my kind of attention shifted towards bioengineering as a young learner. And I guess there were a couple of steps along the way that this path became more obvious. One of the reasons I think it's a good time, one of the reasons I'm excited to be part of bioengineering today is because I think the discipline, the community, is one of a big camp, right? Big tent approach. So you can do many different things, and you can work on very exciting types of projects in the discipline. So that's a very, very good thing about the field. Not every community or the field approaches their studies or their profession this way. So that, I guess, I don't know if I'm answering your question very well or not, but that's how I think about it. So I think the safe bet type answer is that, there are now a lot of very cool opportunities, that stuff that we've learned from biology itself can be kind of like useful, and that's a bad way of maybe describing this, but they can be utilized in a fashion that we mean to use them that way. This is slightly off tangent. I'm, like many folks, I'm really worried about climate change. However, I think because of climate change, like doing exploration in the North or South Pole has become slightly easier. I think we've learned a lot of cool stuff from how aquatic organisms do very unusual things that we don't necessarily, like, on our everyday think about. And we've been able to use, those resources and, for example, build impactful things in the context of our everyday life. So I think we're going to learn in the next, like decade or so, we're going to learn a lot of cool things from how life behaves in those extreme environments. And we may be able to use some of those things that we are learning in building things that are exciting and cool. I love to, like, my students in my courses have heard this story like maybe hundreds of times. They're probably really sick of it, but I tell them about the horseshoe crab and how we kind of just learned about its biology and its cool immune system, and how we utilize that to kind of do drug discovery or working on, biomedical applications. I'm pretty sure there are tons of other examples that are in these extreme environments, maybe at like not as charismatic as a horseshoe crab, but maybe a bacteria that lives in very extreme environments, that we can just learn cool stuff about how that organism lives and be able to use it. So I think, in the near future, those things might be more accessible, for bad reasons, I guess, because of climate change, but maybe, a positive outlook on that. Yeah. On things that worry me, like obviously and naturally, there are some concerns about, some of the ramifications of the field. Like, for example, how we think about using or misusing some tools that have emerged over the past 10 years, or maybe the society is not ready because we have not necessarily done a good job of communicating what is emerging from the field. So that's one thing that I worry about. The additional part that I'm concerned with is that if we don't do a good job of communicating and educating and kind of like really engaging. When I say communicating, I don't mean just talking at people, like actually listening to what they have to say as well. We might not be able to fully utilize, or we might not reach our field's true potential either, right? So there's a concern saying, well, someone will misuse, like, for example, a gene drive, right? That's a real concern, right? Or who gets to decide if we're going to use a gene drive or not. The flip side is that, like, maybe if we don't communicate well, we miss certain opportunities that are really important, right? So thinking about climate change in an impactful way, addressing some of our needs to produce energy or food in a like a healthier way. healthy relative to the planet. So if we don't communicate well to the broader, everyone else in the society who does not have like a PhD in bioengineering, well, we're missing the opportunity. So that worries me a lot. I did not know anything. So here's an example of, I guess I was ignorant. I did not know anything about sand dollars or sand dollar larvae until I started my position as a professor, as an assistant professor. I had just seen sand dollars like essentially at the beach when they were dead, right? this white, I guess their remains. And when we started this project, it was scary, right? Because I was asking a couple of young folks at the start of their academic career, like undergraduate scholars, that's like, okay, we're going to build tools to study this. So I had to sit down and study, right? Right. And it was exciting. It was scary, but it was also really exciting because I am continuously learning new stuff. And I think that's a good mindset to bring to any discipline or any learning environment, but particularly bioengineering as a discipline, because we know very little, and that's a good thing. That's an awesome thing. So to be very honest, I don't know, right? That's exciting and scary in its own ways. One of the things that I hope that would happen is that some of these tools that have been developed and knowledge that's been gained over the maybe past 20 years will begin to present themselves as particularly impactful solutions. Let me give like specific examples. So, if you read, so I do not mean to at all be insensitive about this. I have family members who've suffered and are struggling with cancer. Cancer is a horrible disease. Too many people still perish because of it. And at the same time, if you read the original literature that came in from declaring war on cancer, we have met many of those milestones. We've accomplished so much. There's still a lot remains to be done, but we've done a good deal we've achieved a great deal of progress, and not just by engineers, all disciplines together to address this horrible disease. We haven't accomplished similar, milestones for neurodegenerative diseases. Hopefully, the tools that are emerging through bioengineering, for example, optogenetics is one of them, will enable kind of like fundamental understanding of not necessarily even therapies, right? Fundamental understandings that begin to help us to address some of these neurodegenerative diseases that are really important. The global population is aging. So maybe that's one aspect that I'm hoping selfishly, in the next 20 years that things will get better. In the context of climate change, I think there's a lot of very good ongoing efforts that are folks who are working on projects similar to metabolic engineering of different pathways that can fix carbon more effectively using various types of tools. So maybe that would be a front. So that's like a conservative answer. I guess the more excited answer is that why can't we have bioengineered trees genuinely that are better at fixing carbon, right? That could happen, right? It's sometimes it's very I think we were just briefly talking about the life before internet. That was 20 years ago. It wasn't it wasn't that long ago, right? So it's possible to imagine these things, useful tools and technologies that might be on the horizon. And when they happen, folks just take them for granted, which is okay. It's good. So those are two areas that I'm hoping to see good, meaningful progress. Additionally, I think the way we built stuff, that's I think is less than 20 years. The way that we built stuff, the economics of it is trickier than I think the science part, and that's I guess goes back to this big tent of bioengineering, that we need awesome people, we need excited people who would think about aspects of policy, aspects of business development, aspects of deployment, and how to turn these cool ideas to viable solutions. I was very recent, I don't know if this is true, so take this with a grain of salt. I was recently told that lasers for the first like almost 5 to 6 years that they were invented, folks were just treating them like toys. And I haven't had the time to double check this. It was like, apparently lasers at the beginning were considered this cool technology that was useless. I don't know if this is true, but you know, if there's a remote possibility that that's true, that's just mind-boggling, right? You know, like we use lasers every day and everything today, right? But you know, apparently the inventors of lasers were like, okay, there's this thing, right? And it's kind of cool. but you know, like with that idea, like I think sometimes we can't imagine the impact of a tool or a technology, both positive and negative. But it's definitely a very exciting time to be in bioengineering. With that, actually, I think there's a interesting problem in bioengineering, and that's capacity building, right? The infrastructure for the discipline. You know, there's tons of areas of opportunities for folks who may choose not to want to have like a PhD in bioengineering, and they're incredibly important roles, right? So for example, I think the infrastructure for internet, because we don't see it, we don't think about it, right? But that took like probably, I don't know how long it took to put cables at the bottom of an ocean, right? To enable, you know, like I think that was probably harder if than building iPhones. I'm speculating, I don't know, but I think there are many opportunities for the infrastructure of bioengineering that are really important, and they're going to be fun to think about. And I don't think necessarily to contribute one needs, you know, like a PhD. No, that's fair. And as you said, it's very hard for me to so the first part I think is easy. I think today it's possible to be in high school or even younger and begin to work in bioengineering. So you should not wait to kind of like start college before you kind of like get excited and do something. What you can work in, I think there are now actually maker spaces around biology. There are opportunities with academic labs, with other types of resources. I think there are now kits and tools that folks can buy. We you know, like I think folks in this class will experience using a Foldscope. That's, you know, that can happen anywhere, anytime, and you can explore things. So to begin to explore and do stuff, I don't think you do not need to wait to go to college. That's for sure. I am biased. I'm obviously highly biased because I'm a professor, right? So if you ask me, should we go to college? My knee-jerk reaction is yes. I don't know if that's true or not. I'm just like, you know, telling you my ignorance, but that's my knee-jerk reaction. And I think partially it's not just because of getting a degree or like learning a profession. Those are really important. I was my background was such that I really needed to have a secure financial support for myself after graduating college. So I fully understand that. But I think, you know, other things that happen inside a college setting is like, you know, I grew up as a person, right? I made very good friends that I'm still close with to this day. I kind of like, you know, went to a lot of art exhibits as a college student, which I now don't have time. It's very funny because you would think there's like, oh my God, I'm so busy as a college student. The sad part is that you're going to get busier and busier. So I really had a very good, and I went to a public school. I went to UC Irvine, which was not as popular as it is now. It was still very, very popular, but it was not. I hear UCI is now really popular among UCs, which I take pride in, obviously, for no good reasons. But I think, you know, I had a very good part of my life. I experienced a very good part of my young adult life, I guess, in college. I think you asked me what would I do differently. I'm just going to rephrase that a little bit, like, because I don't know. I'm going to kind of try to answer something that makes me like more comfortable. You know, I think I worry too much about short-term successes. Like, you know, like I had scholarships that depended on my grade. So I worried for good reasons for my grades. And because of that, at least at the first half of my I guess, college career, if you can call it that, I didn't take a lot of joy in some of the things that I was learning or doing. Like I was more focused on the transactional part of like, I need to get an A here. And I think that actually backfired in many ways. I mean, like in a very practical, pragmatic way. In subsequent courses, right, I had to go back and relearn a lot of things that I had an A on, but I just didn't know, right? That was hard, right? The other part is that like I love my discipline. I really enjoy being a bioengineer. And at the same time now, today, I think that it's more important that what you do I think in college is more important than the courses you just take. And also taking courses outside of your immediate discipline are really important. I am genuinely the example of that, right? So I was on an electrical engineering track. I took a kind of like this, I forget what it was called. It was this elective course that I think someone was teaching because they wanted to teach an easy class, talking about secrets of professors. And it was a pretty chill class that they were talking about various technologies that were made for studying biology. And that really captivated, my attention, right? I did not know, like, I think from day one this was a 10-week class. Let's say they were meeting like twice a week. So each meeting, other than the exams, I legit learned something that I did not know anything about. It was like going to this class, and I think the name of the professor was Professor Bachman. He would tell us about this new crazy thing. I was like, what is that? Right? So it's like, and it was electrical engineering adjacent, but it was, not like, let's solve another circuit or let's take another Fourier transform. And that was very good because it really, after that class, I signed up to get a minor in biomedical engineering. I ended up taking more BME classes than EE classes at the end. And that's, really changed the trajectory of my STEM career. The other part that I should have done, and I was good about this, I took a lot of GE courses. This is my biggest fight with everyone in my lab because they're all awesome STEM students. And, like most of them have very, very good GPAs. So we don't fight about anything other than the importance of the GE courses. I wish I was making this up. And I'm in the minority in this, where I tell like folks in the lab that your history class is as important as my fluid mechanics class. If not, it's more important. Because you're not going to use Navier-Stokes with like remembering all of the equation. You'll just remember what it's about, and you can look it up, and its consequences. But like reading and writing well and effectively and thinking about context is something you're going to do for the rest of your life. And they're like, Siavash, just go away. So this is the fight we have all the time in the lab. But I really think that even if you're a STEM student, I think this is perhaps my key takeaway. If you're a STEM student, please remember that your GE courses are critical for your career success as a STEM major and your success as a human being. But I think that's another story. And I'm sad to say I've not made good progress on that front. And it's hard. It's really, I acknowledge that it's really hard when, I still, my lab does a hodgepodge of stuff, which is a reflection of we haven't made up our mind fully about who we are. And that's okay. Like not knowing in this sense is completely okay. Or at least I am comfortable with it. And I think it's just good to have a sense of excitement for learning, and also acknowledging that learning new things is hard. Like that biology course that I took, I almost I'd never struggled with a course as much as that class, and it was so easy to everyone else, but I was like, dude, I don't even know what you're talking about. It's like the words do not make any sense to me, right? And it was funny because I had taken OChem in high school, actually, so I would understand the OChem, but then they would talk about, I forget, but there were so many things and we had this giant Bruce Alberts textbook that was like this brick of a book. So I would sit down and read all of that. But then, I immediately learned that in similar to engineering, I think some folks don't like biology because, like me, naively, I thought that biology is a lot about memorizing stuff. And that's not it at all. Like, there's a lot of organization in this field. There's a lot of, like, when I say organization, I don't mean like cells. I mean like the way that the knowledge is organized. And there's a lot of, like, like many layers, like length scales of how things are organized so that you would get a behavior. But the first time you're learning this, you're just like, what is this pathway? I just got to know this so that I can, like, pass, right? But I regret that that's how our education system everywhere is organized. But if you can take a step back, you should get your good grades. But if you take a step back and try to understand as well, like, why your friends in biology are really excited about this, that is going to, like, give you a lot of very cool opportunities to kind of, like, bring your thinking, whatever it is, maybe it's engineering, maybe it's arts, to that discipline. I think it's really good to learn from a lot of different people that care about very different things. I think the way we think about a major maybe is not fully healthy, even though I am responsible for helping organizing majors in my profession. But I think, major is just a suggestion, right? It's a series of bets that folks who are in that field have placed to say, if you know these things, you know sufficiently so that you can learn for the rest of your life. But, if you may choose not to want to be the carbon copy of Siavash, because I exist, right? You might want to be your own, your own kind of like person, your own, like, bring your own perspective to it. Maybe that's a better way of thinking about it. So taking classes that are, or learning, not even classes, doing things that are a bit not part of that, like, I guess the plan or the path is helpful. I think it helps you think about, or it's been helpful to me. It's helped me think about and learn things that I just couldn't imagine, right? Like sand dollars, I did not know that they look like, the moon lander when they're baby, right? How would you guess that if you've only seen an adult sand dollar? It looks like a circle, right? So it's quite amazing to kind of try to think about things that, or be open to learning and accept. I think this part is important. Accept that learning is hard, right? The first time you learn something new, you're going to feel discomfort, right? Because no one likes to feel stupid. But if you accept that, I think you're going to have a happier time. It's discomforting sometimes when things don't work out the way you'd imagined them. Like, because it means that you missed something or you were wrong. But also it's really, really exciting. That's like, well, there's a new puzzle. And it's, you're absolutely right that because of the way I think our education system is configured, folks are just rewarded for knowing the answer to things that are known. And that's, like, I felt bad the first time I got a C in a biology course as well. I absolutely felt bad, and maybe I shouldn't have, right? Maybe I should have worked hard. But, at the same time, like, the healthier approach is that, well, I learned something new. Yeah, it was hard. and it actually, honestly, didn't have, in limit of long time, it didn't have a negative impact on my career or my life. Genuinely, like, I am not well, one person happens to know, because the person who taught that course ended up being my PhD mentor, actually, in a very funny way. So I think Elliot knows that I got a very low grade in his course, but heck, he hired me after. Right? So like, there's things to think about in that case. So, like, one bad grade did not have, or even multiple bad grades in limit of long time, didn't have a profoundly negative impact on my career. I think it's just important to acknowledge that learning is also really hard, right? Learning new things is just a hard business. So I'm only speaking for me. So, we moved to the US when I was at the end of my high school. And I, like most folks, I think at the end of high school, at the beginning of the college, I had a lot of worries. I had a lot of anxieties. Being in a new country did not help that either. I feel like that's a inflection point for everyone. But there was another added dimension of I guess challenges attached to it. And I actually had to start my academic career at a community college because I had not taken SATs. So I took a year or maybe a year and a half of courses at a local community college before I transferred. And I had this chem professor. His name is Kurt McClendon. And, just by by chance, I ended up going a lot to his office hours. And I didn't know what an office hours was. This is time your instructors have open time so you can go and essentially, I guess, ask questions about stuff. So where I come from, there are no office hours, right? Where I grew up, I guess. And so I just figured out that there's this thing, and I used to go to office hours, and we would not talk about chemistry because I actually happened to knew like most of the material from that class pretty well because we had chemistry in high school. So we would, maybe I had an advantage that way. I was privileged. But we used to talk about essentially like life, genuinely. And that was really helpful to me because, I was in a period of uncertainty, and I am trying to get to this point that Dr. McClendon was not a bioengineer, right? I actually don't know what sort of chemistry he had studied before being a professor at the community college, but he was very instrumental in helping me kind of ground myself at a uncertain part of my life. It just happened that he was an academic. Now, I think it's important to find, I guess this is where I'm going with this. It's important to find folks that are willing to, and I know the word mentor has been used a lot, but people who are willing to help you, whether they're mentors, whether they're friends, colleagues. And I think bioengineering as a whole has a good, I have benefited a lot from many folks who have just been kind and generous with their time in this field. To name a handful, like, Will Grover, who's now a professor at Riverside. He was a postdoc when I was a first-year grad student, and I just sent him an email asking him a bunch of questions, and he answered all of them and sent in everything that he knew. And my project was based on the work he had done as a grad student. He could have thought of me as a threat, but instead he was like, okay, there's this new kid, I'm just going to help him. Polly Fordyce, who's also at at Stanford, she, I remember talking with Polly before, I actually knew her, and she was very generous with her time and answering my questions seriously. And I think bioengineering as a whole broadly has a culture for that. And this is not a reflection of other disciplines. I think it's just, so I don't know how other disciplines are. I'm not saying they're not that way. I'm just speaking for bioengineering. I think folks are broadly pretty open. And I think finding people who are willing to answer your questions seriously and talk with you and willing to spend their precious time with you is really important. And thankfully, this community has many of those folks. I think maybe my small success within the community has been genuinely because of everyone who's been generous with their time. So I think of this as a pay it forward model, and I tell this openly to folks in my lab that this is what we strive for, right? That's what we want, that's an active choice, right? We want to be that way. We could be a different way, but why, right? So I'm not sure if I'm answering your question well, but that's what's on my mind. And I think, for some reason, we don't do a good job, speaking of academic stuff, we don't do a good job of telling folks, for example, what's in office hours, right? I had zero perception of what to expect. And actually, I was very productive because I was not going in to ask for the solution to problem 4, right? I was just going in to be like, hey, what are your thoughts about this thing that's happening to me. And the person on the other end was generous and thoughtful to kind of like give me at least an answer, like not perhaps even the best answer, but just like, this is what I think about it. Now go make up your own mind, right? So I think that was luckily useful, not knowing, what is the expected format. But I think, hopefully newer folks who are arriving in bioengineering, the field has been generally, maybe because of its age, I'm unsure, because of its culture, has been very open. And also, I think younger folks who are now have more agency are very thoughtful about it, and that's awesome. That's something that I take a lot of joy in, to see, like, folks that I was maybe their TA, that they're like, now part of this culture, and they're very thoughtful about, like, the decisions that they make with respect to the community. Oh, okay. That's a great question. I'm going to dodge that question to talk about our science. And I have a good reason for it. So it's not, I'm not trying to like have a favorite project. I honestly mean this. With every, like this, like I'm not very like, I don't have a lot of strong beliefs, but this one is a very strong belief. So, my lab is, so universities are divided in various categories. This is not particularly useful to you. The key thing that you need to know is that my lab is focused on, or my school is primarily undergraduate students, right? So we don't train PhD students, but we do research and we do science. Now, the key outcome from our lab is actually not the science or the projects or the tools. We take pride in the small successes that we have, and we take our work seriously, not ourselves, we take our work seriously. But the key outcome of the lab is the folks who learn how to be, scientists and researchers and engineers. And I'm really proud of that. And I don't brag, but I'm super happy to brag about that for hours. And we have data and evidence to back that part. I did not expect. So when I signed up for my role, I did not expect that we get as much done as we have with, our lab is 10 undergraduate students. These are folks who are taking a lot of courses. And I think the primary thing, this is how I think in 10, 15 years, I am super excited to see where they go and what they do next, not because they're going to work on, building fluidics that help us study sand dollars. That's really cool. I'm so excited about that. That brings me so much joy. I can talk about that for hours too, but I'm really excited to see what else these folks will do as they go on to do cooler and more exciting things that are really particularly exciting to them. And I take a lot of joy and kind of pride in that. And I'm pretty sure that most academic researchers, I'm not at all trying to pretend that I am so unique about this. I am pretty sure that most academic researchers are like me, that they love their science, they're a bit nerdy and geeky, they love to think about like hydrodynamics of sand dollars, which the sand dollars don't care about either. But I think they really are in their role because they want to help folks learn and grow, and they're in it, even if they're not fully aware of it, they're in it for the people who are in their lab or in their class. And I think finding people that are the right fit for you at early stages of your career. It's not like, I'm a very good mentor to some students. I'm probably a horrible mentor to some students because of the way I am, right? So finding good fits with people is very helpful, and being receptive to kind of like, exploring these things. So that's my, I guess, long-winded answer, that I'm mostly excited about the folks that are in my team, and we're working together, and I just can't wait to see what they're going to do, essentially. I'm not sure, but the perhaps maybe the most, this is particularly something that I think about. So some folks are worried about missing out of opportunity. Because of that, they kind of like either don't start on stuff or they jump around a lot. And it's like, oh, I'm going to do a little bit of this, a little bit of that. I just feel like that. Let me put that in perspective of like an experience instead of like kind of like giving a long-winded answer. So when I started as an undergraduate researcher, my first project was on brain-computer interfaces. And that sounded so cool to me. And it's such an important and such a cool research. But in practice, it was mostly programming. I was good at that, but I really didn't enjoy it. And I had a choice, right? The choice was like, I'm going to stick to this and I'm just going to do this. Or I'm going to be like, okay, this is an important opportunity, but I'm not liking it. So maybe I should explore something else. And I kind of think that I was really like, if thinking back, if I was in that person's lab and we're still friends, he's an awesome professor. I got nothing done for real. Like I was a horrible undergraduate researcher, probably because I was, everything I did was like really bad. Probably because I was not enjoying it, right? My heart was not in it. So I think in that instance, I made a good decision that's like, okay, this is not a right fit for me. And I should explore something else. And then I worked on other types of projects. I think being open with yourself in these ways is really important, and not worrying about I'm going to miss out if I leave this, right? There might be nothing else for me. So I think that was really helpful, like being kind of like I've made many horrible bad decisions in that one. I'm happy about that, and I'm still actually friends with the professor whose lab was working on and still works on brain-computer interfaces. They do brilliant, good work, but that was just not for me. So I think that it's I guess it goes back to this idea of most of the things we're going to do, particularly in academic research, is going to fail. It's going to fail. That's for sure. That's the one certainty. And if you don't take yourself too seriously and you're just like, okay, it failed, now we got to do something else. And being okay with I'm not saying be a failure, I'm saying be okay with the discomfort of things not working out. You'll just have a much more happier time, and I would guarantee more productive time in meaningful limits of time. So, and I think I learned that slowly. Like I kind of was not, maybe I made one right decision, but my first few years of my more serious career, I was making bad decisions. It was like, okay, I just got to get this done, and I just got to get this done, and that came to me with with a lot of struggle. And later on, like, well, I learned a ton from this. Maybe it didn't work out the way the science didn't work out the way I wanted, or maybe I didn't get the product that I wanted out of it. But now I can have more meaningful and better research experiences or life experiences because of it. And I think, yeah, that was an important lesson that I learned very slowly. So I wish I'd learned that faster.